So whenever we talk about inequalities, we're talking about less than, greater than, less than or equal to, greater than or equal to. Talking about linear, then that's telling me that my variables are at the first power, the first degree. But we don't write the one up there, but that we know the linear is going to give me a straight line. Anytime your variables are with a degree of 1, then we know the line, it's going to be a straight line. We're talking about two variables here, so let's talk about x and y. We know that that's what we have when we talk about graphing. When graphing linear inequalities in two variables, we will divide the plane into regions called half planes. You're going to have the left half plane and the right half plane, where a vertical line will give us the boundary. Okay, and here's the images of them. If we have, and that's if it's a non-vertical line, so right here you saw that we had the vertical line, that tells me that my slope is undefined, right? It's just straight up and down. If we get some kind of slope increasing or decreasing or whatever it may be, we're going to have a non-vertical line, so we're going to have an upper plane and a lower plane. So we have theorem of graphs and linear inequalities. We have ax plus by is equal to c. And this is in standard form. We have ax plus by is greater than c, where b cannot equal 0, right? If b equals 0, then we only have one variable going on. Here, if we have a is equal to 0 on this one, then once b is equal to 0, we can't have a equal to 0 because then we don't have no variables at all. So this is just letting you know that if in order for have an upper plane or a lower half plane, we cannot let b equal 0. Okay. To have a left, which makes sense. I mean, because what is y? Y represents going up versus going down. So if a equals 0, then we're not going to have a left or a right? Because then that's the x value. It's moving left to right. The procedure of graphing linear inequalities, I'm not going to read all this. This is stuff that you can read, but let's just get started on it. So what we're going to do is we're going to graph this line on here. There's more than one way to do this. However, if I chose to do the intercepts, right, I can solve for it that way. Determine if it's true or not. But first we need to graph the line. Once we graph the line using the x and y intercepts, then we're going to find which part of the plane is true for this because of this inequality sign here. All right, so let's find the x-intercept. And when I do that, I know that y is 0. So when I plug in 0 right here for y, I get 2x is less than or equal to 6. Divide by the 2 to get a positive 1 coefficient on x. 2 goes into 6 3 times. So now we got an x-intercept of positive 3. So I'm going to go from the origin 1, 2, 3 to the right. Now let's find the y-intercept. When I do that, I put 0 in for x. And when I do that, I get a negative 3y is less than or equal to 6. Well, this is a negative 3 on the y, and I'm going to divide by the negative 3. But since it's negative and we're pushing it through the inequality sign actually flips. So negative divides by positive negative. 3 goes into 6 2 times. So I'm going to go to the origin and go down 1, 2. So I'm going to connect my dots, draw my line as best I can. Now I need to determine what part of the plane to shade. So I always like to make it easy on myself. I'm going to find points that are small, and I'm going to start with the origin. Since it didn't fall on the line, I'm going to start with the origin. So let's start with the order pair 0, 0. What does this mean? It means I'm going to plug in for x and y, and I want to see if it gives me a true statement. So I got 0 for x and 0 for y. What happens? This multiplies, gives me 0 minus 0 gives me 0. Is this true? Yeah, 0 is less than 6. So if this is true, then the half that we're going to shade is going to be this half because it made it a true statement. Okay. We will not show the bottom half. So that's it of that one. That's all the work there is for it. On example 2, we notice that we have y is greater than -3. So if I said, what is x? Well, x is not showing. What it is telling me, though, is that no matter what happens, y will always stay at -3. So let's go make our horizontal line. Go down from the origin 1, 2, 3, because y is -3. So I'm going to just pick order pair 0, -3 for sure. And then we can just come out. It don't matter. Let's pick 7. -7 for x. Give me -3 for y. Let's come out here. And let's go 1, 2, 3, 4, 5. Let's use 5 for x. Okay, so I mean, all I had to have was 2 order pairs to draw this dot, but I wanted to draw more than that just because drawing a straight line is hard on the screen. So now what I need to do is determine what part of the graph is true for this. So again, I notice right here, the origin is not on the line, so I'm going to pick it. So if I plug in 0 for y, I'm going to ask myself, is 0 greater than -3? Sure it is. I'd rather my bank account be at $0 than -3. So that's the side we shape. Now, moving to the next one. So we got x is less than or equal to 5. Okay, so what I know is that I don't see y. So I know I'm going to get a vertical line because this tells me x is not changing. However, I need to know exactly what x is in order to graph it over here. So I'm going to divide by 2, get a +1 coefficient. So I got x is less than or equal to 5/2, which what I'm going to go ahead and write it in decimal form because that's going to be easier to plot on here. So it's half of 5 is 2.5. So I'm going to come over here. I got 1, 2. I'm going to do my best to get it right here in the middle. And I'm going to go up 3. You can go down 3. I got my order pair. So if I wanted to write it, I'd say 2.5, comma 0, 3, whoops, 2. Let's erase this. 2.5, comma 3, 2.5, -3. And again, all I need was 2 order pairs. Let's see if I can draw the straight line with that. There we go. It's much better. All right, so I got this vertical line going on, and I need to determine which side is true with this statement. So I'm going to take this 2x is less than or greater to 5. And again, origin's not on there, so I'm going to pick it. So I'm going to plug in 0 for x. 0 times 2 is 0. 0 less than 5? Sure. This just so happens to work out. You know, sometimes it's not true, so we wouldn't shade it. But you want to check over here this, or, you know, even though this is not true, it is true this time, but I'm just saying if it wasn't true, find another point on the other side, check it to make sure that you didn't do a mathematical error. It helps when you use 0, right? Because it just automatically cancels it out. It's very obvious. So this next one, we do have an x and y. However, we got an x is less than or equal to 3y. So what are we going to do? We need to plot it. We need 2 order pairs. Well, it's not as obvious to plot it. So let's just say, all right. Well, you got 2 ways to look at it. You know, you can find the slope of the line by dividing by that 3, and you would have had x is y is equal to 1/3 x. And then said that was a slope, and then add 0 for my y-intercept. You could have done that if you wanted to. There's no reason to make it that complicated. What I'm going to do is I'm going to pick order pair 0, 0. That's my origin. I'm going to plug it in. What do I get? When x is 0, 3 is 0. I get 0 is less than or greater than 0. So I get that point. What if I plugged in 0, 1? Okay, so I plugged in 0 for x, plugged in 1 for y, I get 3 for y. So what I get, no, that's not gonna work. Sorry, guys. That is terrible, terrible. We can't do that. Let's plug in. If I plug in, we can't do it that way. I just made it where it's gonna go over the page. So forgive me. Let's do this. Since y is attached to the 3, let's pick points for y. We picked 0 for y. It gave me 0 for x. I went about it different. Some of you probably caught on to it. If I plug in 1 for y, I'm going to get 3 for x. There we go. That much better. If I plug in 2 for y, or you could have done negative. Let's do -2. You get -6 for y. I mean, sorry. If I plug in -2 for y, I get -6 for x. All right, so now I got the order pairs. Those of you that caught my boo-boo, kudos. Okay, so 0, 0. So when I plugged in 1 for y, I got +3 for x. 1, 2, 3. When I plugged in -2 for y, I got -6 for x. 1, 2, 3, 4, 5, 6. Again, I didn't need all 3 order pairs. I just needed 2. And what happens? It crossed through the origin, right? It crossed through the 0, 0. And I need to erase that. I went about it wrong right there. Okay, so I'm not going to use that. But what I do see is 1, 1 is not on there. So let's try 1, 1. So I got 1 is less than or equal to 3 times 1. Well, that's true. All right, 1 is less than 3. I'm going to try one more point on this side just to make sure. So I see that I got 1, 3. Let's try 1, 3. So when I plug in 1 for x and 3 for y, I get 1 is less than or equal to 9. So yes, I would shade this part here. Okay.